Hello coders! In this video we are looking at a straightforward approach to day 7 of the advent of Code 2022. This puzzle should be approachable by anyone who has learned the basics of coding, but to get the most out of this guide you'll want to be somewhat comfortable with functions, loops, and lists, as well as being able to define your own custom data types using classes or structs, whatever your language happens to provide. I've also posted a link to the puzzle in the description below this video. And of course, if you get stuck, don't hesitate to post your questions in the comments or make a post on the Advent of Code subreddit. There are tons of people there that would love to help you out. If you find this guide helpful, let me know, click that like button. And if you want to see more of the Advent of Code guides, be sure to subscribe so you get a notification. All right, let's get to it. You can hear the birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get here anyway? It appears the device the elves gave you has problems with more than just its communication system. While attempting to perform a system update, you are greeted with an error stating that the device does not have enough room available to install the update. Browsing about the file system, you begin to assess the situation. It appears to be some kind of Unix-like system full of seemingly random files. Perhaps, if you could analyze the contents, you could determine which files to remove. Can you write a program that calculates the size of each folder on the device? Welcome back to day 7 of the Advent of Code. I'm Captain Coder and I'm just about ready to throw this device in the garbage. Luckily, there is a system update that we can install if we can delete some of the junk files that are stored on it. In my opinion, this puzzle is super cool and is a great excuse to model a very simple file system, which will make up the majority of the work. Then once you have that data model available, it's pretty simple, just a matter of parsing the input into that representation. So let's talk about the overall strategy. Let's look at what our input is here. So we have some input. It's going to be a series of commands, and one of the commands is ls, which shows us the contents of a directory. And so we actually see that there's 2 types of files stored on the system. We have directories and we have files. A file starts with an integer representing its size, followed by a name of that file, whereas directories are prefixed with this dir and then the name of the directory. At a glance, we don't quite realize it, but they are in fact in a hierarchical structure. And this is essentially, unless you're using some crazy operating system, this is exactly how files are represented on your computer. Maybe not exactly, but very close. This is a great way to model it. So the first thing we got to do is we are going to define a data type for our ElfFile. Then we're going to define a data type for our directory. When we have those both, then we're going to parse in our inputs into that data model. Finally, with that data model, we can then write a function called find all directories, which is going to pull out all of the directories in our file structure. And then once we have that, it's a matter of just looping over that file structure to find the answer. So we're looking for directories that have at most 100,000 in size directories at most, and we're going to find all those and sum them up. So with our 5-step plan in place, let's dive in. So we're going to define an ElfFile type. I recommend calling it ElfFile, not file. File will clobber in a lot of languages. It's going to be a conflict. It's going to clobber an already existing type. So I'm going to recommend calling it ElfFile. That's what I've called mine. When we look at our data here, we know that an ElfFile happens to have 2 values, a name and a size. So your data model should reflect that. I'm in C#. I'm going to be using a record type. If you're in an object-oriented language, I would recommend using an object or a class. And if you're in another language that doesn't support objects or classes, maybe a struct or whatever data representation your language happens to to support. In this case, I've created a record, very straightforward, has a name and a size, and I have written two static helper methods here. The first one is parse, which is going to take an input that looks like this, which is going to be an integer on one side and a name on the right side. And it's going to actually return to me a new elf file. And then for helping me out later in the future, I'm going to write a little thing called isParsable, which takes in any string and it tells me if it is in a format that we can actually parse into an elf file. To help with this, to give myself confidence that this is going to work, I've gone ahead and written probably more tests than I need to, but I've written some tests here to give myself confidence they're gonna work. And so if I run my program here, so I've built, this program's pretty complex in some ways, so I'm building myself a test harness here. If you're familiar with unit tests, I recommend using those. If you're not familiar with unit tests, follow along here for a minute to see how I'm doing it. But I have a method here that I'm gonna run at the start of my program that's going to give me a report on whether or not I am failing some of my previous tests. In this case, my test reports to me that I'm failing here. So I've written a test here. If I scroll up, we see that ElfFile.isParsable should have returned true, but it didn't match, so it returned false. And then same with isParsable. These two shouldn't return true, so they return false. These are inputs I've stolen from my example over here. And then finally, parsing an actual elf file, it's telling me I should get back an elf file with the correct name and size, but it's not doing that yet. So I've written myself a little test class. If you use a unit testing framework, go ahead and skip forward a little bit. But I've essentially written a little test here, a little function for us called assert, which is going to take in a Boolean and an error message. And if that assertion is false, so the idea is we're going to assert that something is true, and if it's not, we're going to display a little error message to our console. I have mine blasting out in red to give me some confidence right away that I'm going to see it. And then in my main program, I just call run tests, and this is going to check whether or not my tests have passed. If they do, it's going to print out a green all tests pass. Otherwise, it's going to print out a red at least one test is failing to give me a quick view here that I've broken something. All right, so let's look at my test just real briefly so you can see what I'm testing here. I am merely testing expected versus what they actually are. So let me make this a little wider here just for a second. I have my elf file, if I'm parsing in the number here, followed by b.txt, which happens to be an input for my example. I'm expecting to get back an elf file named b.txt with that file size. And I just assert that the thing my parse returned is what I expected. And so if it's not, I'm getting an error. And if it is, I'm gonna go ahead and get that we passed. Similar thing with test isParsable. I go through and I set my test input to various things from my input, and I check whether or not isParsable is returning true. So I have my result and my expected, and I checked is my result equal to expected. If this is false, it's going to show me this error message. All right, so we're implementing two methods here, a parse, which is going to take an input string and return to us an elf file, and an isParsable, which is going to take in an arbitrary string and tell us whether or not it can be parsed. Go ahead and give it a shot. Hopefully you now have a test that is passing for your elf file. If I run mine here, we see that all my tests pass. I get this nice green all tests pass saying that isParsable for an integer followed by a file name is true. The cd command is false, the dir is false, and then my parse ElfFile function, the method here is actually parsing in, taking these numbers and this string and giving me back an elf file that represents that line. If yours is not yet working, go ahead and pause. I'm going to show you my solution here. This parse method is pretty straightforward. we simply take our input, we split it into tokens. There's 2 tokens. The left side is an int, so we parse it as an integer, and the right side is the file name. Pretty straightforward here. And then for is parsable, we check that when we split it, there are exactly 2 tokens, that the first token is an integer. And that's it for our ElfFile test. All right, so the next thing we need to be able to do is figure out how to define our elf directory type. There's a couple things we need to consider here when we are looking at this problem. The directory itself has a name, so that's going to be a property that we need. It also has files in it, so you're going to have a way to store files inside of it. It also has children, so there's directories inside of the directory. So you need a way to have both files inside and a directory inside. And if you've looked ahead here, we have this cd ... We need a way for a directory to know how to get back to its parent. So that's a tricky part here, is having this cd ... be able to get back. So you're gonna have to define a record type that has 4 properties: a name, a list of children, a list of directories, and a parent elf directory. Those 4 things. And if you do it in a clever way, you may only need 3 properties. Hopefully you have a data type now for your elf directory. Once again, I'm using a record type in C#. I have a public name property, a public parent name property, and then I actually have some private fields here, files, this list here. I don't want the outside world to be able to modify it, and I also don't want the outside world to be able to modify my list of elf directories for my children. I want this to sort of be encapsulated inside of this, so I'm following a principle here in object-oriented programming called encapsulation. It's okay if you're not doing this, but it is a good practice to do so. Then I have this constructor here for my elf directory, and I've done a little bit of work here. It's going to take in a name and a parent, and I'm going to set my name and my parent. And then if my parent isn't null, so if this directory has a parent, I'm going to go ahead and add this directory to that parent's child list. So that way I have a reference from my parent to my child and from my child to my parent. Continuing on, we're going to do the same thing we did with our ElfFile. We want to add in a parse and an is parsable function. These are static functions that we can use to generate these. And my parse function for my elf directory, in addition to the input, I'm going to pass in the elf parent that we want to be setting on this elf directory. And I'm sure you know where I'm going next. We need to write in some tests for our elf directory to give us confidence that when we're done with these 2 methods, that it works the way we want. So I've added in a run test that combines a test parse and a test is parsable method. Both of these are testing what I expect the outputs to be. So I start out by constructing a root directory here that I'm going to use sort of as my current directory. Then I'm going to look at this input dir a. That's what we would be seeing in an input file here. And after we parse this, I'm expecting there to be a directory with the name a and the parent root. So I write that test here. I say, does the name of the elf directory that we parsed match the expected? Does the parent match the expected? And then also, did my root get that child added to its list? Similar, I do another test here with B, and continuing on down here for parsable, I do the same thing. I test whether or not these various inputs from my example are going to be parsable by this function. So go ahead, give it a shot, write yourself a test, then implement your 2 functions, parse and is parsable. If all's going well, you have a green all tests pass. You're getting all of your tests to pass. and you're happy with your ElfDirectory parse and is parsable methods. I'm about to show mine, so go ahead and pause if you need to. So here is my solution. Parse, very straightforward. Once again, we merely split it into tokens. We take the second token, so the token, it's going to be dir followed by the name. So we take the second token, and then we just pass the parent in to our constructor. And for is parsable, almost equally as easy. We just check that it starts with the dir keyword. You may have noticed that we currently have no way to add elf files into a directory because we are using encapsulation here. Our files list is hidden. So I've added an AddFile method to my record type here, as well as a method to get the size back. So AddFile is going to take in an elf file and it's going to add it into this directory. And then size is going to actually compute the entire size of this directory, essentially looping through the files and the children directories to get a full size back. And as always, I'm going to encourage you to write a unit test for yourself here to make sure that your AddFile and your size methods are working. So I've written a test here called Test ElfFile, and it constructs this root and asserts that there's nothing in it to begin with, and then I slowly add files to it, checking that the size is correct and that my root's files list contains the new file as we go. Go ahead and give it a shot. If all of your tests are passing, congratulations. I am about to show my solution for AddFile and size. So if you're not ready to see it yet, go ahead and pause. But here it is. AddFile is very simple. I simply take the file that's being passed in and I hand it off to my lists add method. And then size, not too bad as well. I initialize a size value to 0. I iterate through all of my files, adding the size of those files to my size, summing it up. And then I iterate through all of my children, adding their size to my total. And then at the very end, I just return size. And before we continue to parsing here, there's two little things we have to add in. You may remember that in my code, I have private list for my files and my children. I still am going to need access to these when I do my actual parsing, and at the end of the day I need to actually be able to pull all of these children out, but I don't want the lists themselves to be modified outside of the context of this directory file, this ElfDirectory class, this record here. And so I've added in two methods. One's called children, one's called files, and these actually just make a copy of this list so that I get a copy that I can examine, but I can't modify the lists that are on this ElfDirectory record. With our data model in place, we are ready to begin working through the parsing of this problem. I am going to recommend you write 3 helper functions here: process directory line, process file line, and process change directory. Each one of these is going to be responsible for performing the action of a specific line. So for example, process directory line is going to be reading lines like this: dir A, dir D, dir E, dir F, etc. That's going to be reading a specific input and modifying our current directory in some way. And it turns out to be really simple in this case. For this one, you just have to parse it in. When you parse in a directory, it automatically adds itself to the parent. Then for process file line, this is going to be the lines here where we have an integer followed by a file name. When we see those, we're going to call this method. This method needs to parse in that file and then add it to the parent directory. That happens to be what current dir here is. And then finally, process change dir. That's the last one that actually does something. That's these commands here. There's a couple. This one's the tricky one. So I've written a test down here for mine. it is going to take in the current directory that we're in and the input, and then it returns the new directory that we moved to. So there's a couple cases to think about here. We have one where we have this /. What should we do in the case where we have a /? We have the normal case where you actually have a directory that you need to move into. So in that case, you need to actually find the directory inside of the parent and move inside of it. And then we have the last case here, .. This is when we need to move up to our parent directory. So given an input like this, one of these cd commands, what is the elf directory you're going to move back into? And so I recommend going ahead and writing yourself a little test for this change_dir because it's relatively complex. Here I am, all of my tests have passed once again. The test I wrote for process change_dir is passing. I'm gonna show a solution to that in a second, but first let me talk a little bit about process directory line and process file line. These are both relatively trivial, so I didn't write a test for them. Maybe you did, I didn't. But my elf directory coming in becomes the parent that's going to be parsed in, and my input I just hand off to my parse method, which constructs this elf directory and adds it in to the parent on its own. Process file line is also just as trivial. I parse the input and then I add that file to the current directory. I'm about to show my solution to process change_dir, so go ahead and pause if you don't want to see it just yet. And here it is. It's a little bit tricky. It's a little bit tricky here. So I have my current directory and I have my input. In the case of .. I need to go to my parent. So I just say go to my current directory's parent. If I have a /, this really should only occur for the root directory. So I'm going to just say return my current directory. If I get a /, that means I'm at root, and I'm just going to give my root back here. And then the last one is in any other case here, I need to actually go into my current directory, get all my children, and find the matching directory. So I do a little search here for the input name to match a child name, and then I return that one. And the moment we've all been waiting for, we need to build our entire file system. So I've declared a function here, a method BuildFileSystem. It's going to take in an array of all of the rows of input that I need to process, and then it's going to return the elf directory that's the root of my file system. I've gone ahead and set it up here where I get a root, I create a new elf directory @ that happens to be null, and then I need to write the code here in between, and that's going to ultimately build it up. It's going to loop through all of these rows, calling the appropriate process line method that we wrote previously. And to give myself confidence that it's working when it's done, I've written this test here. Let's check that out. Go ahead and run it. It should fail here. It fails. I get an error here. I'm missing my example input. So I'm actually, the way I've written my test here is I'm actually going to test what the result of parsing this in looks like. So I have to create an example file here. And I'm just going to paste that in. And then in my test, I read in that example file, and then I pass it off to build system, and then I validate that this is the file system that's listed down here. So we have our structure here of what it should like if it's correct. Let's run this again. And I get a bunch of red here saying all of the things I'm testing. I expected root to have a child A. I expected A to have a child E. E should have a file I. All of these conditions I'm checking. So once I'm done implementing this, if this is all passing, I feel really confident that this is going to work for a bigger input. Why don't you go ahead and write yourself a test now, implement it, and see how it goes. At this point, I hope you have all of your tests passing and your build file system is working the way you expect it to. I'm about to show my solution, so go ahead and pause if you need to. And here it is, my solution. I After I initialize my root, I also create a variable called currentDir that's going to represent the directory that we're currently in. Then I loop through, I iterate over every row, pulling out the input string and checking if I should call process file line. I check if it is parsable. Call process file line with my current directory and my input, process directory line with my current directory and my input, or if it begins with $CD, that indicates I need to call process change directory, in which case I set current directory to be equal to the value that was returned. And there's one little piece we have left before we can actually find the directories that meet our criteria. In this case, we're going to write a method here, a function called find all directories. It's going to take in an elf directory that we're going to search through. So we're going to take this directory and we're going to search through it, and this method is going to actually return a list that contains all of the directories, this directory plus all of the directories beneath it. So I've started out giving myself a little stub here. I know I'm going to have to create a list. I'm going to add myself to the list, and then I'm going to have to do something where I look at all of the children and sort of get all of the children's directories. So there's a little bit of recursion that we have to do here, and we're going to recur on each of our children and add them into this list. I've written a little test here to give me confidence that when I've implemented it, that it is working. And right now my test, of course, is failing. This little test here is basically I create a root, I create a directory A that is in the root, I create a directory B that's in A, I create a directory C that's in root, and I create a directory D that's in C, and then I validate that that structure exists. It doesn't because I haven't implemented it. Go ahead and write yourself a similar test. See if you can't get find all directories implemented. Good luck. And here I am, all of my tests have passed. I'm about to show you my solution to find all directories. It's a little bit tricky if you haven't seen this type of function before. So go ahead and pause, see if you can figure it out, and then come check out my solution. So the trick here is that we are assuming that find all directories returns a list containing this directory and all of the directories beneath it. So what we can actually do is say, hey, for all of the children in my directory that I'm searching, for all of my children, go ahead and find all of the directories that are beneath that, and then add all of those into the list as well, and then we finally return all of them. So there's a little bit of recursion here that says find all the ones for me, then for all of my children find all of them, and then that's going to find all the ones for those children, and those will find all the ones for those children. And with all of these functions in place, with our data model in place, we are ready to actually solve this puzzle. What we're going to do is we're going to read in all of our input from a file into our arrays. We're going to build the file system. We're going to find all of the directories. Then we're going to iterate over all of those directories, checking to see if each of them meet the criteria. If it does, we're going to add that to a sum, and at the end, we're going to display that total sum. I've just finished implementing my solve method. I've run it against my example input, and I've received the value 95,437, which is the value that we're expected to receive. I'm about to show my solution, so if you need to, go ahead and pause. And here it is. Very straightforward. I take in my file name, I pass that into my build file system, I find all of the directories on that file system, I initialize a sum value to 0, I iterate through, I loop through each of those elf directories, pulling out the size, checking if it meets our criteria, and then adding that to our sum. Finally, I simply report the sum of all of the directories at the end. All that I have left to do is download my input file, pass it in, and see if I can get that beautiful gold star. Hopefully at this point you've submitted your solution and received a beautiful gold star. I hope you found this video helpful. If you did, let me know. Click that like button. If you want to see more admin of code guides, click subscribe so you'll be notified when they're uploaded. And as always, have a beautiful day. Keep on coding, keep on growing, and you're welcome back anytime.